Hello! Welcome to part 4 of the ANSYS tutorial. Um, so, in the past video I went through engineering data and the space claim. Now I'm going to go into this model of the MS-14 chassis. So it says upstream data needs to be reread. Would you like to read the upstream data? All this means is that I have something there already, and would I like to kind of like refresh it and overwrite what I had before? And the answer is yes. So it's going to take a tiny bit of time to load up, and that program that is loading up right now is called Mechanical. So it's called ANSYS Mechanical, which is sort of where you set up your mesh and everything in your model. So I think it's still loading. Yeah, it's still loading. Alright, there we go. Okay, here we go. Now we have our model kind of set up in ANSYS Mechanical, and in this program we're now going to set up the mesh and get everything set up to be simulated. And this is sort of where you perform your FEM, so your finite element method, which you can kind of like learn about more on your own. It's just called FEM. But here, what we need to do, so right now it kind of assumes everything is just kind of static structural, or structural steel in this model. That doesn't matter for now, because in the next step we're going to overwrite that a bit. But here we just need to assign some materials to it. So for now I'm just going to make everything 4130 chromoly steel. So maybe I can do that like that. So all the beams are going to be material, and make that 4130 chromoly. And again, this is from the engineering data we made in the past video. And then all these other solids, so these ones, these are all the gussets. These are also going to be 4130 chromoly. And then all these impact objects, it doesn't matter too much what material they are, so I'm just going to make it structural steel. And then for all these surfaces, so you have to assign a thickness. This thickness can be arbitrary, because it doesn't really matter how thick it is. It's going to be overridden in the ACP setup, which is the next step again. So I'm just going to make it like a really thin like assignment, and this is just pretty much just like what it will show. So like don't make it 1 meter thick, because then it will show a 1 meter thick surface and it will look kind of weird. So just make it really thin. And then for the material assignment, it doesn't matter what it is, it's going to be overridden. So I just put structural steel. Now, if I go back to the bottom, this entire ANSYS workbench has already been kind of set up before. So previously, I already added in these point masses. They just need to be reassigned to the model. So like if you're starting this from scratch, you have to kind of just like right click anywhere really in this geometry folder. So up here, your geometry, and you just click insert, and you want to insert these point masses. The reason why we're inserting these point masses is so that we can have a proper simulation. Because with these point masses, which I will apply, and if I then go to, never mind, I thought it was here, it's not here, but once I apply these point masses in our simulation, I apply an acceleration, and in order to get the proper simulation requirements, which is collisions at 5 Gs, I need to accelerate it at 5 times 9.8 meters per second squared, and then with the proper mass, you have F equals ma. So you have the proper mass of your model, and then you have the 5g acceleration, and then you can get the proper force you want applied on your model. So to apply these point masses, So here I have a 160 kilogram point mass, so I just apply that to this surface, I think, because that's where 2 passengers will sit, and each passenger is 80 kilograms. So that's 160 in total. Here I have 100 kilograms. I think that's for the battery box, so that goes at the top. So I'm just applying this to the surface, and that just applies 100 kilograms on that surface. Here I have another passenger mass, so apply that to that surface. And then I have 2 more 100 kilograms, which I just apply to the front and back walls to kind of simulate like the weight of the wheels in front and back. Yeah. And another special thing you could do with these point masses is that you can create these pinball regions. So if I click on, for example, the battery box point mass, the battery box won't lie or won't apply 100 kilograms on this entire surface, since the battery box is only a box sort of in the middle of the surface. So in order to only apply the 100 kilograms on that section of the surface, I want to create a pinball region, which I think is in millimeters, or it's in meters. So apply pinball region in 1 meter. If you look here, where this blue ball intersects with the surface I selected is where the 100 kilograms will be applied to. So 1 meter is a bit big. Let's try half a meter. Yeah, so I think the battery box is like around that size, maybe a bit smaller. But you can see where this ball intersects this surface is where the 100 kilograms is going to be applied to. And you can also change the coordinates of the pinball region if you want to move it like more to the front or more to the back. Yeah. Then after that, I would then just close the geometry section of it. And now you want to create your connections. So everything is still kind of like floating around and not kind of connected. These are the connections from the old simulation, so usually you want to have this here, so I'm just going to delete it. So you'd have nothing here. What you'd want to do is that you want to insert a connection group. And then in your connection group, if you go to details of connection group, you have a bunch of different settings. So if you want something that is face-to-face, so 2 different objects that are connected or are really close to each other face-to-face, if you want that to connect, you just make that yes. If you have something that's face-to-edge, you want to set that to yes. So yes. And then edge-to-edge, you also want that to be set to yes. After you have these 3 yeses, you then want to create your automatic connections. And this will detect all the connections and make them for you. So now if I go into my folder, you'll see that I'll have a few hundred different types of connections. And if I just click on one, you can see, for example, now on the right, you'll see a contact body view and a target body view. And that just shows you what 2 things you have connected. And each one of these contact regions is something being connected to something else. So for example, contact region 541, that connects this top beam to the back wall, it seems like. Yeah. And yeah, this does this for every single contact in your model. So you'll have a few hundred for sure in it. So yeah, after that's done, you could close that up. And then you want to generate your mesh. So you want to insert a, you have a few different tools that you can use with your mesh. So you can do like a mesh sizing, refinements in certain areas, things like that. So you can just click on generate mesh, and then it will mesh all of your parts for you. And if this takes like a super long time, it might be because your mesh is too refined. And if it's really quick, you might want to consider making your mesh like more, I guess like accurate or like smaller. So this is like okay. I'd say this mesh is a bit is not like the finest it could be, but it's definitely okay for now. Another thing you can do after this, lastly, that you probably need to do is that you want to create these name selections. So you can create them through this way, or you can select whatever you want to create a name selection of. And what a name selection is that it's just a I guess like a certain selection of faces or edges or nodes on your part. And later on, when you apply like your stack ups, if you want like a certain surface to be like a different type of stack up than everywhere else, you would need a name selection for that certain area so that you can kind of like identify where that special surface is, where you want to do different things to it. So for example, with the bottom panel, we are planning to make the kind of center part of it a bit thicker with more layers of carbon fiber than the bottom panels. And the reason we're thinking of doing that is because of this shape, it kind of sort of will act like a spring, and we want it to be like super rigid, so we're going to add some extra carbon fiber here. So if I select these faces and I hold down Control and select all these faces, so this area is where I want to apply something different, which I won't do yet. I'll do that in the next step, but in this step you have to get it set up. So I select all these surfaces, I right click, and then I want to create a name selection. And then I'm going to call this selection, I'm just going to call it the catamaran. Yeah. And then I just click OK. And now it pops up, and now you have this catamaran name selection. So that's pretty much it for the model. Let me just check the time. Yeah, so that's pretty much all I would go through this video with. And again, so pretty much what I did was set up the geometry, set up the connections, generate the mesh, and create any name selections that you would need. And there's not much you have to do with the collision objects. You just kind of like leave them floating around here. And then like in the later videos, you'll see why, what I do with them. But yeah, that's pretty much it for this model portion of it. So again, now we finished the model, and in the next video I'll go through the ACP setup where we set up all of the composite materials and the layup and the stack ups and the surface bodies in our model. So yeah, that's pretty much it for part 4.